Hello, everyone, and welcome to Statistics. So, we're starting this new topic today, and all I want to do in this video is just give a brief outline, sort of a roadmap of what we're going to be doing, as well as to define statistics and talk about its significance. Now, all statistics is like when we looked at measurement in the previous topic, statistics are a man made invention. They are a mathematical tool that we have provided, and it deals with collecting data from, say, a population set, some population. Now, when we look at, for example, a country's population, I'm from Australia, so there's a lot of people. We've got this kind of, actually, I'll draw it on this side. Oops. We've got this massive data set with a bunch of different people. Well, we have maybe, I won't call it a data set, but we have a lot of people in our population, millions of people, right? Now, it is very difficult on any given day to collect information about a whole massive set of millions of people, right? So statistics is all about finding things out about our population, about certain groups, certain demographics. It's all about gathering data and essentially measuring this data. And obviously, as we said, it is implausible. Well, it's too much of an effort, for lack of a better word, to gather all of this data on the right. Pretend these little dots are millions and millions of people. What we can do is that we can take a smaller set of data, so we can collect a more manageable data set. So say we were looking at the height of our entire population, right? We're not going to go and measure every single person out of these millions of people, but we can measure kind of 1,000 people in this smaller data set, and we can use the information we get and some of the measures we'll be talking about soon to infer, to apply this to a bigger population. So it's all about taking information from a smaller set, and we're looking at making predictions, or we're looking at gaining some insight to infer things about a larger population. So we can apply this to many different contexts, right? Taking data sets from certain schools and how students performed in a math test. And we can use that to make predictions or make statements about the greater education system as a whole. Now, obviously, if you're a critical thinker, some alarm bells will be ringing. You'll be saying, well, there's just so many factors at play. What if the school that was picked was a very low performing school? It didn't have historically good results, and you're using this to make this grand prediction about the population. That's flawed, and you would be absolutely right in saying that. So there have been books written about this, right? There are certain fallacies with statistics, and there are some issues, kind of this basic level of statistics we'll be learning encounter. So obviously it's not a perfect system. It is a thing developed by humans, and things in the real world, as we talked about in measurement, are not perfect. These are not perfect systems, but they can be useful tools. Now, I talked about the school analogy before, right? So taking one school, for example, and using that to predict things and talk about the entire education system in Australia, not a good idea, right? What if we were to take 10 schools? Well, okay, you could still argue, well, some of the schools you may be looking at are in a maybe like a wealthy area, and they're a bunch of private schools. So these still aren't taking into account the whole population. But by adding more schools, say we looked at 100 schools or 200 schools, the bigger our data set is, the bigger this thing on the left here is, the more of a range we're going to get of schools, the more the picture's going to become clearer. Imagine, say, you those pictures where you'd get where it's like you get all these like dots and things, and then the more you add, the more it makes like a painting or something. Sorry, that's a really bad analogy, but you won't get this with, say, 10 dots. But the more dots you add, I don't even know if this is making sense, but you may have seen those videos with, like another image made of a bunch of small images. That's kind of the idea I'm getting at, is that the bigger our data set, it puts us in a better position to make, infer, to make these kind of statements on a larger scale. So that is the crux of statistics. It is taking a little sample out of our entire population and then inferring things, making statements on our larger population. And out of that little thought experiment I talked about with the schools and taking exam results, we will notice a trend that, well, the more data we take, the larger our data set, the stronger case we can make. So more data is better. More data is more useful to us. It paints a clearer picture. And that, in terms of an intro to statistics, is all I'll leave you with. But in this course, we will be looking at the measurements of data. So I will call these the 3 M's. So there we go. So 3 M's. I'll define these in a minute. But we have mean, which is similar to average. Average is a term you may have come across before. We have mean, we have the median, and the mode. I will define all of these in probably the next video. And we're also going to look at the range of data sets. And I've split these up for good reason, which will become clear shortly. But we are going to be studying these different measures of data. As well as this, we'll be looking at a number of different data sets and how we can plot data, how we can visually represent things we have collected. Now, this data can be anything you can measure, anything you can think about. So it can be heights, it can be the scores of students in a test at school. It can be kind of any information that we can collect. So I'll leave you with that. And in the future videos, we will look at these ideas of mean, median, mode, and range, as well as the different data sets we use to measure or make these statements about our larger population. So the kind of basic data plots that we use in statistics. I'll see you in the next video.